Okay, I'm going to live code a solution to version 2 of the WordBucket. So I'm going to copy my original WordBucket. Actually, I'm going to do it this way. So I'm going to copy my original WordBucket, and I'm going to paste, and I'm going to call this WordBucket 3 because I already have this other WordBucket 2. Okay, so the main idea of this WordBucket was we were replacing our array list of strings with an array list of, I'm going to call it word frequency, which is our own object that holds both a string for the word and a frequency for how many times we've seen the word. So I'm going to call this entries, and in the constructor I will say entries equals new array list. And now I have to go through and fix all the things, but before I do that, let's actually make the word frequency class. I'm not going to add any of this to get yet. Go, private string word and private int count. And then if you want to, you can auto-generate the constructor. On a Mac, you can hit Shift-Shift. Apparently on mine as well. On a PC, you can hit Control-Shift-A and search for constructor. And then I select the two fields, and that's auto-generated by constructor. Same thing if you want to search for getter and setter. You can auto-generate the two getter and setters. Cool, so now I've got my object. Going back to the WordBucket. So if I'm adding a word to the WordBucket, this is the most complicated of all of the methods, actually, so I'm going to postpone this to the end, but let's do some pseudocode. So I want to loop over entries to see if, or let's say to find an entry for word. If there is none, then I want to create a new entry with count 1 and add it to the list. Otherwise, I want to increment count for the entry and then shift it so it's in sorted order still. So at least now I've captured my steps. Let's also postpone this add. Let's assume that adding works and that we've got an entries list that looks the way that we want it to look. So size is supposed to tell me what's the total size of, what's the total number of everything I've ever added to my array. So in that case, I'm going to make a counter. I can't just return the size of entries because that's the number of different words that have been added to my bucket. I want to know how many total words have ever been added. So I'll make count start at 0. I'm going to, again, use a for each loop here. So I'm going to loop over all the entries, and I'm going to add onto the count entry.getCount. And then at the end, I'll return count. And I'm going to make this long because we might be using this for very, very large data sets. Okay, for get count of, this is great. All I have to do is find the target and then return the count. So let's do this. We're probably going to go back and rewrite this later once we sort of take account of what other methods we'll need. But for the moment, I think we can do this. We can say, I'll use a entries.size, and now I'll say word frequency entry equals, what am I trying to do? Entries get I, and now if entry.getWord equals target, then I want to return, you know, I perfectly well could have used a for each loop here. So if entry.getWord equals target, then I'll return entry.getCount. If I never see it, then I'll return 0 because this target string was never added to my bucket, so therefore there are 0 of them. Okay, get most frequent is now a lot simpler. I can return, well, let's make sure it's not empty. So if size is bigger than, so if size is equal to 0, then I'll return the empty string. Otherwise, I'm going to return entries get 0 dot get word, because I'm storing these in sorted order, so the most frequent should be the first one. Get num unique is also a lot simpler now. I'm just going to return entries.size, because that's the number of different words that have been added to my bucket. All right, so now let's go back and tackle this issue of add here at the top. So here's a student solution that I want to improve upon. So we've got this contains Boolean, and we're looping over all the entries in our list, and we're checking to see, do any of the entries equal the word we're trying to add? So the purpose here is, if we've already added this word to the list, then let's find the entry for it and increment the count. So if we do find it, then we go ahead and get that object, and we set the count to be whatever the count used to be plus 1. So that's incrementing it. And then we know that contains equals true because we've done it. And so if we get to the end of this thing and we've never seen it, we've never set contains to be true, then this is going to be true because we know that the thing didn't contain the word we were trying to add. So in that case, let's make a new object for that word whose count is 1 and add it to the end of the list. And then the student hasn't yet implemented the thing that will put things in sorted order. Okay, so let's clean this up a little bit. So the first thing is, this line right here is a very awkward way of trying to increment the count. Well, let's back up even further. So whenever you find yourself saying entries.getI multiple times, that's a good signal that you probably want to save the object at index I into its own variable. And in this case, I'm noticing that I never actually use I for anything. I don't care what the index is. The whole point is just to find a thing. So if I wanted to rewrite this, it would be a little bit cleaner to use a for each loop. So let's do that real quick. Word freak, we'll call this word, and then entries, and then I don't, now instead of saying entries.getI, I can say word. Oh, I can't call these both word. Entry. So I'm saying if my input word equals my entries word, then do something. And then here I can say entry. And then here I can say entry. So that's already a little bit cleaner. We probably don't want to say set the count to whatever the count was plus 1. It would be a lot cleaner to say add to count 1, something like that. So now I can create that method where I'll say count plus equals to add. All right, great. So that's a little bit cleaner. Let's step back one more time. I'm noticing that I have this pattern in a couple of places. I loop over all of the entries to see, like to look up the entry for a particular word. I do that here. I'm probably going to need to do that in this add. I'm doing it inside of getCountOf. So that seems to me like a fundamental thing that I'm going to want to be able to do. So let's make a private helper method instead. So instead of like doing this right in here, let's go ahead and, well, let's go ahead and do this. So get entry for, and then I give it word. So if I had this as a helper method, I could like literally look up the thing that I want. And then once I have the thing that I want, I could say item dot adds to count 1, for example. But then I'd have this method available in other places if I wanted to do other things. For example, down here, I wouldn't have to repeat this. I could say entry equals get, what did I just call it? Oh. Get entry for, it wasn't auto-completing because I hadn't actually created it yet. So same thing, and now we can say if entry isn't null, because I'm imagining what are we going to return here if there is no entry? I guess we'd have to return null. So if the entry isn't null, that means the entry exists, in which case we can return entry.getCount. Otherwise, we'll return 0. Cool, so now we've made our code a little bit shorter by reusing this single idea. Let's go ahead and create it. So this is where we have our for each loop going from word. Oh, I see why you guys are always doing this. Ooh, I don't like that. So word frequency, entries, and then if entry.getWord equals target, return entry, otherwise I'll return null. Okay, so this add is getting a lot cleaner than the way that it started because we've divided it into these helper methods. And now we don't need this contains anymore. Instead, we can say if item equals null, then let's go ahead and assign item to be our new one. So in other words, if we didn't have an entry for that before, let's go ahead and make one. And now, no matter what, we can go ahead and add it to the list. Oh, no, sorry. And now, no matter what am I trying to do here? All right, so let's make one, and then we'll say entries.addItem. Otherwise, we'll say item.addToCount. Great. So look up the item. If we didn't find it, let's make one and add it. If we did find one, let's add to the count. And now we're in a nice position to be able to sort so that the things are in sorted order. The problem is we don't want to perform a full sort of the list because that would be very wasteful. It's pretty slow to do a sort. And the list is already guaranteed to be in sorted order. The only possible thing that might be out of order is item. But the problem is this method returns the actual object, so we don't know where this is in the list. So it's a little bit hard to figure out how to reorder the things in the list right where this is because we don't know where it is. So let's go back and refactor. Instead of get entry for, let's do get index for. So get index for and that one is going to be very similar. Oops. We'll have a for each loop that loops over everything. And if entry get word equals the word we're looking for, then we'll return. Oh, I can't use a for each loop here. Okay. How do I? So let's do iterate list. Is that what I want to do? Yeah, that makes sense. Cool. All right, so here I'm looping over all the entries, and now I can say if entry get word equals word, I'll return I. Otherwise, I'm going to return -1 to indicate that it didn't exist. Okay, so now that we've got that one, I get the index. And now I can rewrite this a little bit. I can say if index equals -1, then let's go ahead and make an item and add it. And we'll set index to be equal to entries.size -1. Otherwise, let's go ahead and look up the item. Entries.getIndex. And there it is. And now we're in a good position to sort it because we know that the index is correct. We know where the thing is. And I'm going to go ahead and make that its own helper method. I'm going to call it sort item at index. Move word frequency object at index into sorted order in entries. So I'm just remembering what is it that I'm doing here. Let's think it through for just a second. So let's say that I had incremented high. So now high is 6. What I want to do is I want to shift this to the left repeatedly as long as the entry to its left has a smaller count. As soon as the entry to its left has a larger count, I know it's in the right spot in the list. I also have to be careful about going out of bounds, because as soon as this is shifted far enough that it's the first element, the element in index 0, then I don't want to check its left-hand neighbor because there is no left-hand neighbor. So that's the kind of idea. So I think I'll use a while loop. Oops. I think I'll say while the index of the thing I'm trying to shift is greater than 0, because if it's equal to 0, it's already the first thing, and I'm not going to shift it. And entries.getIndex.getCount is smaller than, no, what am I trying to say? Is bigger than the one to its left. Entries.getIndex-1 get count. Then I want to swap them. So maybe I should have a helper method here. Swap elements. I'm going to give it the entries list and the 2 indices that I want to swap. Cool. I think that will probably do it as soon as I have swap elements. So let's make swap elements. I'm going to call this one I, and I'm going to call this one J. Oops. I'm going to call this one I. Okay, so let's do this. Let's say word frequency A, or like entry 1, equals entries.getI, and word frequency entry 2, entries.getJ. By the way, there's a built-in thing to do this, but I want you to get the practice making it yourself. So what are we doing? We're getting at the 2 things, and then I'm going to say entries.set I to be entry 2, and entries set J to be entry 1. Cool, so that has now swapped them. Does that make sense? Entry 1 came from I, and now I'm setting it to be J. Yeah, okay, great. Is this the absolute most efficient thing we can do? No, because we're repeatedly swapping things. It would be slightly more efficient to remove it from where it is, figure out where we want to insert it, and then insert it there. But if you want to do that, you can do that on your own. So we're almost done with the object now. I think add is probably working, although we'll want to test it in just a second. Let's look at... I'm going to move these private helper methods to the end. So let's look at the multiple adding one. So last time what we did was if I want to add many of a thing, I just ran my own add method that many times. That's going to be super duper slow now because if I want to add something 37 times, really I just want to add to count 37. But here I'm going to over and over and over again look up the location of the word and then add to it one at a time, which is very slow. So I don't think this way of organizing it makes sense anymore. We could copy and paste this code and then instead of just adding 1, we would add count. That's not very dry, however. So I think here's the right thing to do. Let's make this the primary version of our method, where we'll add count. Oh, that's long, so now I've got to make everything long. Cool. means probably that, yes, everything's got to be long now. Should have thought of this the first time. All right. And now, in this one, I can just say, let's add word with a count of 1. So if I just want to add one thing, I'm going to run the more general version of my own method, and this is where all the logic is contained. Okay, that's it. I hope it helped.